So, welcome to the 24th virtual meetup. Today, we will be having Andres. And before starting, a huge shout out to Browser Stack, our exclusive sponsor for all our community events and premier sponsor for conferences. Now, about the speaker, about Andres, I'll just call him on the stage. Just a second. Hi, Andres.
Hello, everyone.
How are you?
I'm fine. It's too early or too late
Yeah,
uh, in Argentina, so I'm I'm okay for now.
yeah,
It's
perfect.
great because it's more simple for me. Okay. The idea of this talk is improving the performance of your microservices, and perhaps you think, okay, what is the impact of this topic on testing? Well, sounds interesting because many of these things affect in the case that you, for example, create a performance test. So there are some things that you need to consider. This is the brief introduction, but first, I need to explain who I am. My name is Sacco. I work as developer since 2007 using different languages. Most of them are connected with the JVM, Kotlin, Scala, Java. I use it in other languages. Some of them appear on the presentation. I use another ones like Haskell, which is not so popular. I participate as technical reviewer on different editorials like Apress, O'Reilly, Pack, and many. Also, I publish some books, courses, live projects. Some of them appear on the presentation. My last book not appear on the presentation, so I need to update this. And last, I participate as a speaker on different conferences. You have my contact information, my LinkedIn, my email. So if after this webinar you have any doubts, any question, and I don't know, tomorrow you remember or you have a question, please contact me by LinkedIn, by email. I part of the community on Discord, so contact me and I will try to help you as soon as possible. So let me explain the context of the problem. You have a platform that have different kind of microservices, and that microservices have some kind of problems. And which type of problem perhaps you can have? First one, you have too many requests. You have a microservices that expose certain information, like, I don't know, a catalog with the information about the currencies, cities, countries, or many things that are not static but not change frequently. And the other microservices on your platform do a lot of requests at the same time. The other problem is the size of the response. Well, the request on the response is too big, the request on some endpoints. You have also communication problems. You have some random problems, errors on the communication between different microservices. Of course, this affect at some point the performance, the latency, many other things. And the last one is the concurrency. Many requests at the same time try to obtain the same information. Of course, if everything it's okay, you will obtain on the different requests the same information. So let's explain a little about each problem, which things affect. And you have latency, availability, cost, and the use of resources. Resources imply how many servers, how many instances of a microservices perhaps I need to consider. Also implies CPU and memory. So for the first one is what happens when I have too many requests at the same time to obtain the same information. This affects everything because increase the latency because you do a lot of requests at the same time, and perhaps the other microservices which contain the information don't have a lot of instance to return or to accept all the requests at the same time. So at some point, affect the entire latency or the entire time to respond in one of my microservices. Of course, affect the availability, because if you receive too many requests at the same time and you don't scale your microservices, will affect the entire platform. Many requests at the same time to obtain the same information, depending on your cloud provider, you will pay for each request that you do to obtain information. So at some point you need to think, okay, we need to reduce the number of requests, and implies that you need to use or have more CPU, more instance of your microservices. The next one, the size of the response, of course, affect the latency, because you need to move move the information, a big piece of information from one place to another place. This takes time. If the piece of information is small, takes less time. It's the same that, for example, when you try to download something from internet, if the file is too small, you download quickly. If the size of the file, I don't know, have a size of 1 gigabyte, takes more time than the other one. Not affect the availability, because if the size of the response or the request not affect the availability, the microservices continue working without any kind of problem. Affect the cost, because most of the cloud providers charge in your bill the cost associated with the transference of information from one place to another place. And of course, implies more resources, because you need to spend more memory and more CPU to process the response or the request from the different microservices. In the case of communication problems, only affect the availability, because if I do many requests to another microservices and all the other microservices reject or have some kind of problem, I spend a lot of money to do the request and I don't have a valid response. So affect the availability and the cost. The resources and the latency is not affected for this. And the last one is the concurrency. At the same situation, the first one affect everything, because you spend a lot of money, increase the latency to do the same request to obtain the same information. But the main difference with the first one is to obtain some kind of static information. The last one is to obtain dynamic information. Imagine that you go to Amazon or this kind of e-commerce and you want to do a search for a specific product. This is a dynamic query or request, because you want to obtain information if available or not the product. If for the first one, imagine that you need to save or load your address, and when you go to your account, the option to select your country is static, because it's the same every time that you go to that place. So, okay, why these approaches could fail? Why these situations could produce some kind of problem? First one, because you don't document the decision of the or the process that you use. So you had 4 different problems, and at some point you have a solution and you introduce the solution. Why this could fail? This is the idea of this. First one is because you don't document nothing. You don't have like a page on Notion or Jira or something like that. You don't have nothing. You don't consider the trade-off. of the different alternatives is like, okay, I want to use this alternative because I like, or because I heard that is the best option. And you analyze the pros and cons of each alternative. No, and you don't document. It's connected with the first problem. The next problem is you only tackle one part of the problem. You only consider some kind or some part of your platform, not the entire platform. It's like, okay, for example, I have two microservices that use Java and the rest use, I don't know, Go. Oh, okay, we will use some solution for the applications or the microservices on Java. Okay, and with the rest, well, we'll analyze later. You need to consider everything. Of course, perhaps you have different libraries or different implementation, because Go and Java don't have nothing in common. And the last one is like thinking just in one particular language or framework. This is the thing that I mentioned. And all these kind of things, or all these things that I mentioned, could apply for the tool that you choose to do testing. If you analyze, most of the things are connected. Okay, how we can deal with this static information? It's used for many other places, many other microservices to obtain certain information. So you have like one microservices that accept many requests from different parts of the platform. The information does change frequently. Again, how many countries appear in a year? How many cities? How many currencies? So this kind of information don't change frequently. Of course, I try to explain with a simple example, but for example, in your company, perhaps you have different examples of static information. In my case, that the things that always use as a catalog of information is something static for me. But the main problem with this kind of microservices or this kind of application is that you need to have a high availability, because many microservices use the information. And why is so important, this problem in particular? I do just a little stop. Imagine that you create a performance test on the entire platform or a stress test to check if everything looks fine or not. What happens if you do many requests from one microservices, or the microservices that start a specific flow, that do too many requests to another microservices? Will affect many other things that I mentioned before: the availability, the latency, the cost on your cloud provider. So this is so important. Okay, as I mentioned, could be an API of cities and countries, and perhaps you can create or define a mechanism to say temporarily the information, because it's the same information many times, or don't change the frequent. So what is this possible solution? The cache, perhaps. And what implied this cache? Well, first one, reduce the traffic between the different microservices. It's the same that, for example, on the web page, when you enter in some web page, you download some files, and the next time that you enter in the same website, load quickly that the previous time. So this is more or less the idea of cache. There are multiple ways to implement this. It's like proxy, in-memory, external. Each of them have some kind of pros and cons. You need to consider, this is one thing that you need to consider, is the number of elements that you want to save in the mechanism of cache, the size of these resources, because it's not the same that you save in a mechanism of cache, I don't know, 1,000 elements that only have two attributes, like the code and the name of a city. It's simple, it's short, it's small. But what happens if you need to save in a mechanism of cache an entire JSON that have, I don't know, 100 elements? It's so different. And then the last thing that you need to consider is the time, because it's not like, oh, I say forever. No, you need to think that at some point you need to reload the elements or expire the information. Try to combine different mechanisms of cache. There is not a silver bullet. It's like the best alternative to solve this is to combine different alternatives. You need to find a way to invalidate the cache, just in case that you should change a lot of things in your microservices on the other microservice. Imagine that you detect that there is a problem with the name of a lot of cities, and you fix it, and you need to invalidate the cache of the other microservices. And try to think the solution in an agnostic way. Again, try to not think, oh, I want to use this framework or this library. No, okay, we have this kind of problem that, for example, we detect it on a performance test or a stress test, that these microservices suffer for all the requests of the other microservices on the platform. So, okay, how we can fix this problem? Using a cache, and I will do this. And after that you have how fix it, try to think in the library that or the tool to implement this. Okay, let's explain each time of cache, because I mentioned a lot of time cache, and there are different alternatives, and each of them have a specific purpose. So the first one, which is the most simple, is cache in memory. And what imply this type of mechanism? First one is saving information using the memory of each instance of the microservices. So if I have, I don't know, 10 instances of the same microservices, I use a small piece on each instance, on each server that run my microservices, to save this information. Of course, are not connected. So the instance 1 have some kind of information, the instance 2 have another kind of information. It's not the same. So imagine that you have some kind of problem, but for some reasons or some situations could be a good option. Not all the microservices have the same information. There is not a mechanism to synchronize the information in the most simple implementation. If you scale up or you scale down, you don't have information on the cache. So imagine that you have 2 instances of one microservices. For some reason, your application scale up to 10 in different instances. The new instance not have nothing or anything in the cache. So when they receive the different requests, they will populate this mechanism of cache. In the case of Java, there are some implementations like Caffeine and Wawa, and use this again as a mechanism to save static information that not change frequently, and is not relevant to have some kind of synchronization between the different instances. It's like, okay, if one instance have some values on the mechanism on the cache and the other ones have another, it's okay. I can live with this problem. Take in consideration again the size of the object. Here is so important because you use the memory of your microservices. So you need to limit or limitate at some point the size, the elements, and the duration. Next problem, or the next mechanism of cache in proxy. This is totally different because instead to save the information inside of each instance of my microservices, I have a tool to save this information. So this information, I have like my microservices, and in front to my microservices, I have a tool which could be Varnish or Nginx, and the consumers of my microservices think that they connect directly with the microservices, but in fact pass through the tool. So the tool receives the request, detect if have the information on the cache, if have the information, return the information, and if not have the information, okay, the tool do the request to the real microservices. It's like a facade. You don't know that there is a tool or a mechanism of cache in front. So with this approach, you solve the problem that, okay, different microservices have different information. It's one central place that receives all the requests at the same time and load all the information on the mechanism of cache. Nothing happens if your microservices scale up or scale down because you have another tool in another server that contain all the information. So it's agnostic. The biggest benefit of this is that you don't need to modify your consumers. It's not like, oh no, I need to introduce a library, I need to do a lot of modification on my code. No, it's okay. I only run the tool, and for the rest of the universe, they think that is real microservices on that port, on that host, but you know that there is some layer in front of this. One thing, again, here is define the expiration for each endpoint and each element that you save in the cache. Because, again, it's a tool that run in a server. So this tool spend memory and CPU. The best approach is reduce the time to live of the different elements, the TTL. And the last one is a little variation from the first one. Remember that I say the different instance of my microservices not have the same information. Well, you can fix this using a mechanism of external cache. Instead to save in your memory, you push the information in some database and you check on the database if the information exists or not. The request go to the database and after that go to the API. And with the other approach, instead to go to the database, check on the memory. It's more or less the same, but instead to check in the memory, check in external resource. Nothing happened. It's connected with the previous solution. Nothing happened because you have in a central place in a database all the information. So if the microservices scale up or scale down, will not affect the information that you have on this mechanism of cache. Slime implementation and Redis and Memcache. I always suggest to use Redis because have different features like is fault tolerant, so you can have more than one instance, and in the case that some of the instance fail, the the service is available. And the main problem with this solution is increase the cost and the maintainability, because again, you need to have an external services like Rails or Memcache, and this implies cost. That implies that someone need to check if available or not. I showed 3 different alternatives. The idea is that you combine. So what things you need to consider when you use this mechanism of cache? You have different types, as I mentioned. And here is the most important part. Not put attention on the different types, but just put attention on the duration, the frequency of the change, and the relevance of the information. Frequency of the changes imply, okay, how many times some value of that microservices change. And it's relevant for us. Okay, it's not the same, for example, if we save in a mechanism of cache, I don't know, the cities or the countries or a list of currencies. Don't change frequently. But imagine that you save, I don't know, the markup of a product in a company, or how you can calculate the price on some kind of products. So this is so relevant for us. And so the frequency of the change is need to be different that in the name of a cities or a countries. So these kind of things you need to consider. And last one is you need to consider the size of the element. Again, how many, which is the size of the request or the response that I need to save, and the hit radio. What is this? Perhaps you can think the hit radio is, after that I save an element of a cache, how many times the different consumers do the same request that I have the information on my mechanism of cache. Next problem, the size of the information. Okay, what is so important? First one, as I mentioned, if I have a big file or a big response or request, increase the time to send and receive the information. If I have an alternative to reduce the size, I take less time. Perhaps this is so common, perhaps you don't need all the information. I do a request to obtain some information from an user. I do the request and obtain the information, and perhaps I only need the first name and the last name. And the other attributes for me is not relevant. I discard. So I spend a lot of money and a lot of resources to only use 2 attributes from a response that contain, I don't know, 50 elements, perhaps. Could be dynamic or static information is not relevant for us. We do a request, and the relevance of the problem is the size of the response. If it's static or dynamic, for us is the same. And again, as I mentioned, always increase the cost associated to transfer this information depending of your cloud provider. Some cloud providers charge in your bill the transfer information from different places. So you need to consider these kind of things. And the last one implies that you use or spend more resources, memory, because you need to process a big response, and CPU. So how we can solve this problem? Well, the first solution is like compress the information. Like when you need to send a big file or a big set number of file, and you say, okay, I will compress in a zip file and I send by email. It's more or less the same, but the using the communication between different microservices. So this reduces the size of the data during the transference. Increase, here is the main problem, increase the use of CPU to decompress the information. You compress the transference of information. So at some point, the one microservices need to compress the information and the other one need to decompress. This depends of the different implementation, the different languages. But for example, in the case of Java, when you start to compress something, increase the use of the CPU in at least 5%. Depending of the size of your servers or the type of your servers, could be a lot of resources or could be nothing. I say 5% considering a medium or normal server. In the case of AWS, is a T3 medium. You need to define how you compress and decompress. Some languages have this automatic compression and decompression, like Node.js or Java, Kotlin, and Scala, and many others, like detect that in the response happen a specific header, and with this header say, okay, I need to decompress. And for us, it's like transparent. You never see that the information is compressed. As I mentioned, implies that you need to add a header to specify that the response is compressed. Another alternative to this, which in many cases is implemented, that you can implement the compress of the information before to save the information in a compressed way, like for example Redis, or you can indicate on some point to say, okay, I want that the transfer of the information from my microservices to the database need to be compressed. And when the message arrives to the database, decompress and save the information decompressed. As I mentioned, some frameworks do automatically, naturally, so I don't need to do nothing. Okay, I remember that I mentioned and that I compress my information, but what happened in the case that only need to use 2 attributes for a big response and I discard the other one? Compress could be an option, but while I can use another one. You have different alternatives. First one, you can create another endpoint that only return some specific information. Okay, I create like the same microservice, the same endpoint on one microservices, and say, okay, only give me the first name and the last name of my user. Or this is another option, is like not create another microservice, another endpoint, use the same endpoint and say, okay, I send an extra parameter in the URL and you ignore some attribute on the response. And here is the best alternative on these kind of things is use GraphQL. With GraphQL, I only say, okay, I only want the first name and the last name, and the other attributes it's not necessary for me. So at some point, you be more effective on the information that you travel or you ask to some microservices or some endpoint. And the main problem with this solution is who maintains all the endpoints, all this kind of solution. Okay, dealing with concurrency. Concurrency is many requests at the same time to obtain dynamic information. Could imply complex operation to obtain certain information. Again, if I need to calculate the price or a product or I need to do a search for a specific category of product in an e-commerce, this implies that I do a complex operation. I need to find a product that match with that description, calculate the price, check if, I don't know, if that product could be delivered to some specific country. So this operation takes time and imply many things. It's not like obtain static information. Because again, you sites like Amazon manage like a stock of products. Or imagine that you have a travel agency and you sell flights. The number of seats in a plane are small. It's not like infinite. So you need to do some kind of operations. Could be not connected with static information, could be, but the concurrency here is more connected with dynamic because the idea is to save time. And what happened with this implies an increase of resources to do the same. Imagine that this kind of events like Black Friday, Cyber Monday, or this kind of big popular events where a lot of people at the same time try to do a search for a specific product. So what happened? All the requests at the same time be executed. This implies that you spend a lot of resources like memory, CPU, instance of your microservices, the cost associated to transfer information from one place to another, all these things just to obtain the same information. Again, imagine that I do a request, I do a search, and 1 second after that, you do the same request. So both requests at the same time do the same. So I need to find a way to say, okay, some of these operations need to be wait or need to not be executed. How tackles these problems? Well, the first one is the mechanism of cache. It's the first solution. But the main problem with this mechanism of cache implies that, okay, not at the same time, because imagine the mechanism of cache solve the problem when, for example, I do a request now, and 10 seconds after that, you do the same request. With this approach, the mechanism of cache solve the problem. But again, if there is a small difference from both requests or a big number of requests, the cache not solve the problem. So it's a possible way to mitigate the problem, but not solve the problem. Limit the number of requests. This is not the best solution, but it's a possible solution. Imagine that you want that the site continue available with this kind of huge event. So you say, okay, my microservices only accept 10 requests. Great. And when someone do the request number 11, will return an error in an e-commerce on these huge events. Is not the best solution, the best approach. So the last one is use a mechanism of semaph. It's like at some point see or delegate on the which of the requests pass to and execute the entire flow, and which wait until that everything it's okay. So what imply the use of semaph? Because it's not free. They have some cons and pros. You need to create a barrier. You need to create something in some part to indicate, okay, I'm the first request to obtain this information. I need to create a barrier to indicate to the other requests that will do the same, okay, someone do the same request at the same time. I need to wait. So the first one execute the entire flow, and the others that appear after that wait until that the first one obtain the information. Implies that the other requests wait. And you need to create, this is so important, you need to create a mechanism to notify the other requests. Okay, I'm the first request. I obtain all the information about the availability of one product. And there are another requests that at the same time trying to obtain the same information. So I need to find a way to say, okay, you are find this product, the information of that product. I have the information. I share with you. Instead to say do the request to the entire flow pass through different microservices, is like I share with you the information and you only return. At some point, increase the use of resources like the memory and the CPU, because you create a barrier and the other requests are waiting. This implies that use or increase the use of CPU and memory. And again, it's ideal for travel agency, e-commerce, these kind of sites that need to sell a lot of things in a huge kind of events. The last problem is problems with the communications. So you have random failures on one or different microservices. Could be in the middle of the entire flow. It's not like, oh, in the first request that I do, something failed. No, could fail in any part. Implies that you waste a lot of resources, because if in some part of my pipeline fail or my flow fail, I waste a lot of money, or resources to process the information. Imagine that you have an entire flow of requests, and at the last request and the last part of the flow fail. All the different things that I process during that, I will lost. And bad working implies this. So perhaps my platform will not respond something. For example, if I find a product and something fail on the communication, perhaps the platform say, oh, we don't have this product on the platform, and it's a lie. It's not a good answer. And here is something connected with testing. How we detect this kind of problems? We can detect this with chaos engineering. Chaos engineering is something vital in this kind of problem, because you need to create like some kind of scenarios to check if the entire platform or some part of the platform works fine or not. Chaos engineering is like introduce that some part of the platform fail. Is like, okay, what happened if my database fail? How the platform continue working? Or what happened if I stop that microservices? Or what happened if I stop the other one? So you need to create different scenarios and detect the possible problems. How tackles this problem? First one, there are different approach, some manual, other automatic. There is not a solution. It's more connected with the chaos engineering, so you need to detect which things that you can solve and which you can solve. You need to find the problem. Where is the problem? On which part of my platform? Again, you do a request. Imagine that you create like an end-to-end test, and using the real implementation of the microservices, and some part fail. You don't have information about on which microservices fail. You do a request and you obtain an exception. So you need to spend time to find a problem. You need to consider different alternatives to mitigate this, and this imply perhaps you can use like some patterns of resilience, like a fallback method. Okay, if something bad happened on my microservices, instead to throw an exception, I will do this behavior and I will return a result. As I mentioned, use resilient solutions. You can use different, there are many of them. The retry is a possible solution. Do like you on your microservices that execute uh, a request. Perhaps if something failed, okay, I will retry. And if after 3 times that this request fail, I will return another object or an exception or something that it's more friendly for the consumer. What implies that you use this pattern? First, you need to define which patterns you will use. Again, there are a lot of patterns related with the resilience, like circuit breaker, fallback method, retry, many other things. Which strategy you will use is like each microservice is define the different patterns, or you have something in your infrastructure that do everything for you. Okay, define the threshold. Okay, how many requests I start your mechanism of resilience. Define the alerts. It's something bad happened, and you can combine with other mechanisms that, okay, in the case that something bad happened, I will use a mechanism of cache. Some best practices to finalize my presentation: show or analyze the entire picture, not just one microservices. Try to think on the entire platform to understand what implies this. Analyze the trade-off of each implementation, of each possible decision on the platform. Not generalize, like, okay, not assume that one solution works for all the situation. This is connected with the first one. Look the entire picture. Document the solution, please. Create a document and a small document and say, okay, we will use this solution and the trade-off of this imply blah, 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 the pros and the cons. Think on the problem, not put the attention on the libraries, tools, many other things. It's like, my problem is this, and I need to fix in this way. After that, think in the libraries. Combine different solutions, like the mechanism of cache, you can combine. And here are some books that you can use or you can read for this kind of problem, and some blogs connected with testing and this kind of problem. Again, most of the things are connected, or you can detect with different kind of testing. Like with chaos engineering, most of this problem you will detect. And in the case of the problems related with the use of cache, with a performance test or a stress test, if you create in a good way, you will detect that, okay, these microservices suffer a lot of requests at the same time. You need to find the developers, or you need to find a way to solve this. So thanks. This is all from my side. So if you have any doubts, any question, feel free to ask.
Hi, Andres. We have few questions here.
Okay.
I'll just read it out. Is this one of the good reads understanding multiple different instances, microservices? Sandeep have posted a link. And then what else do you recommend to study? What readings you recommend for caches?
Okay. Yeah. Okay. You can have let me explain or split the question on different things. First one, it's like different instance, different instance of the microservices imply that you have in your machine or in a cloud provider or every place running at the same time both two or more times the same microservices. And in the case of mechanism of cache, um, I recommend that there is not a specific resource that I can say, okay, read this book that I solve all the problems. I put on my presentation some books. I think that building microservices, and there is another one. Let me check. Okay, fundamental of software architecture. This is explain more or less the different mechanisms of cache in more in deep. So if you want to check more information about these specific topics, not related with the testing, you can check building microservices from Sam Newman and fundamental of software from Mark Richards and Neil Ford.
Okay, perfect. Next question is at the time of design of microservices, solution architecture, and deciding cloud, hosting, infra, and configuration, what critical and useful role a tester must play?
As I mentioned, the testing will help to the developers and the architects to detect possible point of failures. Imagine that you suppose that your platform is robust and everything works fine. After that, you create like a stress test or performance test, and you detect that most of the platform not support, I don't know, a specific number of requests at the same time. So it's your responsibility create some test of stress and detect this kind of problem, because most of these problems appear when you create like some kind of a scenario that use a performance test or a stress test. The communication problems you can detect using or creating like a chaos engineering. Chaos engineering is like, as I mentioned, a practice to think an hypothetical situation and see what happened with my platform. It's like, okay, the microservices A communicate with B. Okay, what happened if that disappear or is down? So at that point, you can help to the developers to detect this kind of problem because are problems.
Okay. Next question, I think this is the last question. Best way to test microservices?
Whoa. Uh, I don't have a specific answer to this, but I will tell that the things that I always use. I prefer to create like an integration test, like using Cucumber or Karate, like as a black box. So I don't think in I need to create the test inside of the microservices. I have an external repository, or I don't think in the language of the microservices. If the microservices use Java, it's okay. If use Go, for me, it's okay. So I use Karate to define the scenarios. And one thing that is great of Karate is that you can reuse the scenarios, the things that you define. Okay, I need to do a request to this microset to this endpoint with these parameters, and the response need to be this, like a common scenario of testing, and you can reuse this to define your stress test. So You only say, okay, I want to run this scenario 3 times in 20 seconds, and you check the results. I think this is the best way to test something outside of the microservices, or not think in the specific language that the developers use.
Yeah, perfect. Feedback form. By the time, Andre, thank you very much for taking our time. Any closing thoughts for taking from the questions or the experience? I know I think now it's 3 a.m. In Argentina. You took out the time. We are very, very grateful for that.
Thank you to you and and the rest of the community to create this kind of events. It's so important to us share different experience and different things, because if not, there is not a way that we can obtain this kind of information. You have some information in your experience, I have some information in my experience. The best
Yeah,
way to improve our quality as developers and testers is
yeah,
share
yeah.
our knowledge.
Perfect. Perfect. Thank you. Thank you very much